Hello everybody, this is Dr. Sergeysarkisov, and right now I want to discuss mathematics of personal finance. I want to teach you a few important concepts that will help you throughout your academic and work, careers there. So let's look into some of these things. A few concepts. He begins kind of with this idea of interest, right? Something that, let's say, you owe somebody money and you have to pay them for borrowing extra. The interest is extra. Or let's say you're lending somebody money, and of course, with that you're expecting interest, like it's almost like a tax, right? An extra that you will be gaining based on the fact that you are letting them borrow your money. So you're not having that money now. That's the disadvantage. But the advantage is when you get it back, you'll get it back with extra called interest. So let's discuss simple interest first. Simple interest is kind of a direct take on getting this bonus, this interest. So let's call it interest I, okay? And what the idea is, there's a formula for it, and I'll explain it first. Over time, it accumulates basically linearly, okay? Where you would say, you know what? You would say, let's say there's a present value, okay? There's something that you, basically a principal, right? A principal is something you initiate with. Like, let's say you let somebody borrow some amount of money. This is called the principal value, okay? And you have a rate of interest. So PV is present value, okay? That's what that is. Or, it's kind of a principal per se. So it's the amount borrowed or deposited, in this case at least. And then look, oops, let me do this here. Let me kind of take a little touch on this and bring it down, okay? So we're also going to talk about I, I is interest. That's what I was talking about. And then we have here simple interest now, is interest. We're going to talk about some notation just to kind of use it throughout this class or this lecture here. So I is interest, okay? We're going to talk about R being the annual, usually we'll talk about annual when you see R, annual interest rate. So annual is the yearly, okay? And usually, you could say it over what time you're having that, but usually the R is the annual interest rate. For example, if you do half a year, you would say half, you would multiply the half by the R, okay? That's the idea there. So annual interest rate, okay? It's the rate, it's a percentage. Now we have to be familiar, comfortable with percent. For example, 20% is 20 divided by 100 as a number, as a fraction, which is 1/5, right? 20% is 1/5. Or you can do decimal, 0.20. It brings the decimal point from 20 point to not 2.0, but 0.20. You bring it left 2 times. So anyway, R is interest rate, and let's talk about time, T. T is time, okay? And so what happens with interest rate, with simple interest, you have this present value, right? And you multiply that by the interest rate, right? So this is how much extra is going to be on top. It's like, I'll give you an example in a bit. And then times the time that you're accumulating it over, okay? That's what simple interest is. It just comes kind of linearly over time and increases. Let me give you an example here. So let's take a little bit here on the color difference. So let's do this color, okay? So look, for example, if you have, let me write example. Let's say you give principal amount, okay, borrowed, let's say, P, and it's going to be present value really because you start with that. Let's say it's equal to, let's keep it basic, $1,000, okay? And maybe the annual interest R is equal to, let's say, almost like a tax, let's say like 8%, okay? And maybe the time, let's do kind of 2 times. T1, one idea is maybe you do 3 years, okay? And the other idea is maybe T2 would be 3 months, okay? So we have 2 examples here. So let's talk about what would be interest with 1, with the T1, right? You would say, you know what? It's equal to that $1,000, okay? Now the interest rate is 8%, so it's actually going to be $80 that you're paying interest every year, okay? 8% of 100 is 80, so $80. And then times the 3, because you're doing it 3 years. You see, everyone, 3. And that would give you, what is that, $240. And that's extra, right? So if you want to talk about future value, what future value is, let us write a formula. It's going to be the present value plus, it's going to be the interest plus the present value, or the present value, let's see, plus the interest. In other words, what you have now plus that extra, that's the future value, what it becomes, right? The total. And then you can also write the formula as, factor out the PV, so PV times 1 plus RT. A lot of times people see this formula, and they don't know where it comes from. For simple interest, it's that. So here, let me underline the formula is important for us. FV equals PV times 1 plus RT. And of course, interest, I equals, one second. I equals, let me do that again. I equals PV RT, okay? So there's one example, and let's do the I2. In other words, let's imagine we had the T2, right? This one, at this point, 3 months. Well, yeah, you have 1,000, and let's write 8% is maybe 0.08 if you want. You can also say it's 8 over 100, or 4 over 50, or 2 out of 25, like with different, if you want to do fractions. And then 3 months is actually 3/12, right, of a year, which is a quarter. You know what that's going to happen to be? That's going to be $20, right? Instead of 80, it's just going to be $20. So let's say we have, I'm just not do the dollar sign, so $20 interest. And so let's say future value, the first one would be 1,240, right? 1,240. And then the future value of the second one is the 1,000 plus the 20, and you would have $1,020. In other words, think about it. Over a longer period of time, 3 years, you're gonna, it's gonna accumulate more by $240 more. And if it's just 3 months, it's just a little bit. It's just a $20 more, right? Okay, that's simple interest. Not much more to be said about that. I think it's kind of the lightest of concepts in my financial mathematics. Okay, but what happens later is there's something called compound interest. Okay, compound interest is a little different. It's when you have this idea of the growth of it over time. In other words, let me give you an example. Let's say we have payment, right? Let's say we talk about a present value principle. So let's say we have let me give you an example first this time. Let's say we have $1,000 is our principal. So let's say we invest, let somebody borrow, right? So anyway, we have, this is present value, $1,000, huh? It's kind of principal also. Principal is kind of what you begin with. That's a different kind of terminology. But present value is like what you have right now. So that's why there's the same here. Okay. So now, let's say you have the same. Let's make it easy. Let's do percentages like R is 5%. Okay. Maybe let's compare this with before. Okay. Now, what happens over 3 years? Okay. Here's what happens. Let's say T. Let's just do 3 years. Okay. Usually this is an annual rate. 5% annual rate. What is the future value? Here's what's going on. Okay. Okay, let's do interest. Every year you have a little bit different of interest because look, let's kind of break this down into year 1 right now, 0 years go by. Then 1 year goes by. Then 2 years go by, right? And then 3 years go by. And so kind of let's do this kind of separator. So okay. Now 0 years, what do you have now? Okay, you have $1,000. Woohoo, right? Then there's no interest, so it's like kind of like PV is this, and interest it has been none, right? There's no interest. We just started. Now, after 1 year, now we can see what happens. 5% just times 1 year times the $1,000. That's going to be $50, right? Let's see if we do dollars, $50. So what do you have now? Now you have the value, kind of not present value, but value, like future value almost, but like future value 1. Or I'm just going to put, I'm going to just put right here on this, just a number, $1,050, right? Now, you over the year will charge 5% more on top of this number. Okay, everyone? You'll charge it. Let me get a calculator here. I have one near me. So in case I don't have to make a mistake with 1.05 times 15 or 1.05 squaring it, right? Which is actually not impossible. It's I think it's like almost like 10.25% extra instead of 5%. So a little bit extra. It's going to get even bigger than $50 more. So watch this. If you do this and now interest on this, guess what happens on the 1050? Let me do this. 1050. What did I say? Yeah, and then times 0.05. Now you have an extra $52. 0.5 more. And then of course we had. Okay, 1 second. Let me do this. Yeah, and then so this is extra, right? More. So now we actually had $102.50. You see, I had to add them up. And finally, if you do it again, so what is this? That's going to be now add 52 to 50 to this 1050. And you get, what is that? 1,100, right? $2.50, okay? So you see, it's growing more than just 50, 50, 50, like simple interest. You have now 50, and then you have 52, 50, and then let's see what happens. If you do 5% of this now, 1,100, $2.50, okay, and you multiply by 1.05. Well, let's do that just by 0.5. You get now more by $55. Okay, $55. Okay, this I'm going to show you a little breakup. We get a formula for doing this all together. Okay, and this is the money, and you can round it 13 cents, of course. And so when you add this all up, you get, this is called the future value. Actually, it's going to be 1,000. Look at this, 1,100. 50. I can see $7, and if you do that 13, it's going to be about 63 cents. Okay, everyone. But now look what happens. Okay, this is what a nice formula would be. Interest. What happens? It's kind of, it goes up and up and up. But if you do the future value, right, what happens? You remember that we had present value times, and then plus the interest, right? Let's do kind of over one time, right? Let's see. It's going to be present value times, remember that formula, 1 plus RT? Now remember that. Now, RTT is 1 over 1 year, so just 1 plus R, okay? And we do it one time, so kind of to the first power. Now, what happens is now this is the future value 1, okay? Let's right here, future value 1. Let's call it future value 2, and that's kind of the end right there, then their future value period. All right, just future value. So future value 1 will be this one time, and as we have that, right? Future value 2 will now be, you're working with future value 1. That's the thing about it. So you do future value 1 plus the interest, and then this interest is kind of that's interest 1, that's interest 2 now. See, this is interest 1, this is interest 2, and this is going to be interest, just interest. And so now look at that. That's going to be what? That's going to be that PV, that future value 1 is actually, let's write this, PV times 1 plus R. Okay? And interest 2, what happens? You needed to do it again on that thing, right? So it's going to be, on this, you have times R again, right? And we have to add it to itself. So it's going to be this, future value is this, and then interest 2 would be PV 1 plus R, just that future value 1, and then times again the R, okay? That's the idea. The interest, goes up by another R times that, the rate of that. So it's going to be actually, if you distribute this out a little bit, PV times 1 plus R, another 1 plus R, so it's R plus 1 plus R squared. Check that out. Again, I know it's a little tricky to see this, but this is what? I1 is actually just PVR, okay? And I2 now is that new, is FV1R, okay? Because you did a rate on the future value 1, basically, okay? And that's what happened. That's what we used this there to get this formula, okay? Here's an important one, okay? So now what happens, what do you think will happen with future value 3? In other words, the future value. It's just going to be future value 3. That's our future value. Actually, we did 3 years. That's going to be FV2, right? Future value 2, the one we just had, plus the interest, the new interest 3, the third interest, right? And that's going to be, by the way, third interest will be interest on that future value 2, okay? And so what happens is that's the rate, times the value. And that's going to be what? Future value 2, if you look at that, it's going to be 1 plus R. And by the way, future value 2 was already, remember, present value times 1 plus R squared. So it's going to be 1 plus R to the third power now. Okay? And so, of course, you see what happens every year. So the formula is, remember, 3 is what? That's the T. Okay? T is 3 years. So if you have any T, guess what happens? We have our future value equal to what? The present value times 1 plus R to the T, not just 3, but any number of years, okay? That's what it goes on. Now, you can get a little messier. What if you're doing compound interest not just annually? What if you're doing it, let's say, every so often, right? Sometimes that's something that happens there where you're like, what's going on? Why am I doing more than, like, let's say you're doing monthly interest versus, versus this idea of just doing it annually. If you're doing monthly interest, let me just kind of give you a little heads up here. Future value, let's make it a little nicer looking. 1 second. I want to make it look nice, right? At least if nothing else, let's do interest. I'm about to have to teach a class actually right now, to be honest. Another class. So I may have to end up here sooner than you like. But anyway, let me actually write this in a different color here. It's kind of like a little kind of important. If we take interest every, let's say, month, for example. Okay. Then, here's what happens, okay? Let me show you. Okay, every month, there are 12 months per year, in a year, right? And so that would be, let's call M the number of periods. So M, so let's call it number of these periods, of accumulation periods, right? Or, the interest periods. Number, let me put number periods. Call it M, or it's a nice number to use, a letter or whatever, right? Is equal to 12. So how many per year, right? So our interest, so the period interest per period, monthly interest, call it I for interest, is equal to not just the annual, but R over the 12, okay? R over the M, okay? And so it's going to be actually, what is that? Whatever we have, R over the 12, right? So let's say, again, let's do examples with, what is that, $1,000, principal value $1,000, and let's say we do monthly, so principal value, let's do the same thing, $1,000, R was 5%, and then T was 3 years, but we're going to do this, M is now not once a year, but actually 12 times a year. So what we would do is then we would do, let me show you, you would say future value is equal to, you have present value, right, $1,000. I'm going to put $1,000. Let's keep it money for now, just the numbers, okay? Times, remember the 1.1 plus R, 1.05, okay? You would think, but no, it's actually not. 1 second. It's 1 plus I, okay? 5%, it's not the rate. It's actually 5% over the 12, because you're really doing just, divide by 12, because you're doing 12 times a year, okay? So it's divide by 12. But you take it, everyone, 12 times each year for 3 years. So that's 3 times 12. You see that? That's 36 times you're doing that. Okay? And you'll see it's going to be even bigger than what you're expecting above. Okay? So here, future value, when it was done yearly, ultimately ended up to be right here, right? Let me show you, right there. 1,157.63. Now this should be even bigger. Watch this. Not significantly, but watch. Because the interest rate, 5% is not like 25%. But watch this. It's going to equal to, let me kind of do this on a calculator. And if you ever need to know what to do on a calculator, watch this. You do 1,000 times 1, and but let me do this. 0.05 divided by 12. You will get 0.00416667. Let me kind of not round it too much yet, okay? It's actually the kind of the 6666 continuous, right? Kind of that, the fraction with a bar, the decimal with a bar over it, right? The repeating decimal. But anyway, we have this, and we take it to the what? We take it to the 36th power, right, everyone? Now, to do to the 36th power, there's a button on the calculator. It has a hat, okay? That's the power. So you do this number, then the hat button, and then this number. Or there's a button my calculator usually has. Let me show you what my calculator has. Or this button here, okay? X to the Y, or Y to the X. There's like a power. So it's the same button. Calculator, okay? Right, calculator, so you understand what I'm doing. If you had a calculator, because you need a calculator for this, right? Nobody's going to do this in their heads, right? I'm not. So, and then to the power of 36, and I multiply that by 1,000, and I get, everybody, 1,100, very close to what we had before, but $61.47 about, okay, if I'm rounding to cents, okay? And that's, you see this one right here is bigger than that 1161 is bigger than 1157. Not too much, because but it's something bigger. It has to be. All right, let's go from here to something called, let's do the last thing, annuities. Okay, so these are payments you make over time. Annuities. I was going to do some other things like present value, but annuities, it's you do every period payments. I'm going to just kind of hurry this up. Payments made per period. Again, we've done this already with many of you in a class earlier. So let me kind of just simplify to, let's talk about ordinary annuities. There's ordinary and annuities due. So ordinary annuities, and we will not have time for annuities due right now, because I'm about to have to teach a class. And annuities due. Annuities due is like when you do before, okay? So let's say what I mean. Let's say we do per month. You pay at the end of each month. Let's say you're paying rent, right? Now, annuities due is a little different. That's like you pay you pay and then you can live for a month in a house, and then you pay and then you live. Like for example, if you're renting, right? Anyway, here's what happens with annuities. And let's just talk about this ordinary annuity, right? Like kind of at the end of each period, end of period. Payment made at the end of each period, and then payment made. This one is payment initially. Okay, in the beginning of each period. So anyway, let's do this right here. We're going to do the ordinary annuities. What happens is this. Every payment is going to be accumulated over this time. Compound interest, okay? So what happens is, let's give it an example, okay? Let's say we do 5 years, okay? 5 years. And let's do like 4 years, a little bit less so we can kind of see it. So let's say we have T is 4 years, okay? Let's say we are doing, let's do like quarterly, okay? Quarterly payments. So quarterly, that's what? There's every 3 months. M is equal to, let's put this in parentheses. M is equal to 4 instead of 12, not monthly, but quarterly. Okay. Let's say rate. Annual rate is 8%, for example. Okay, so easy numbers to divide and all that. Okay. We're talking about $1,000 still. Make it easy. It's a principal. Okay. Present value. Actually, one second. So that's not what we would do here. We're making payments of maybe, let's say, $200 payments. Okay, PMT is what it's actually used for, payments, business term, payments. And what happens is, let's say, what do we actually come out with as the kind of the future value, right? What do we actually get? Let me explain what happens here. It's a little tricky, okay? So what happens is, okay, let me show you some pictures here. Let's do 0 years. Let's hurry up here, okay? 0 years, 1 year, 2 years. We did 4 years, 3 years. 4 years, okay? Let me spread out just a little bit too. Oops. Let's highlight this so we have a little bit more space. Okay? And let me do this. Okay, everyone? Okay, now look. Here's what goes on. At 0 years, yeah, we have, what is that? We actually, 0 years, we have first quarter payments. So first, let's see, let me show you 1 second. First period, we have 4 periods, right? Period 0, 1, 2, 3, 4, period, right? That kind of 3 months periods. Then we have here first, then we go 5, 6, 7, 8, right? Then we have, then again 4, 9, 10, 11, 12. You see the periods? Then we have, what, third year, we have 13 periods, 14, 15, 16, those are the payments. And then fourth year, you're going to be making the 17th, the 18th, the 9th, well, 1 second. So after 1 year, let's say, goes by, you have made, let me kind of make it a little neat, understandable more so, okay? You start with the first payment, the 0th payment, and you got to the 4th payment after like 1 year is there. Now we go 5th payment, 6th, 7th, and when we get the 2nd year, we made 8 payments. Now we go 9, 10, 11, and the 3rd year we got 12, and then 13, 14, 15, 16 is the last payment we make at the end of the 4th, kind of at the 4th year. And so, when you do this, you make the first payment here, right? Let's say $200. Okay? That's it. Now, by the way, what would be kind of the overall payment you would actually be making? Like, what are you actually depositing? Let's say the deposit. Let me kind of do this. Net deposit, let me kind of use that terminology for us, okay? Is going to be $200, right? And how many times? 4, right? And how many years? 4, right? So M, let me actually say payment, right? Let me kind of get the dollar sign. Payment times the M times the T. Makes sense? So we do it, how many payments are we making? We're making the 4 times the 4 because 4 years, 4 times, 16 payments. And so we have 200 times the 16, 4 times 4, and that's going to be, what is that? 3,200. That's kind of what we're actually investing. We're putting in 200, 16 times. But really, because we're doing that, we're actually going to get a lot in return because, look, the 200 itself will become 200, and then over the next month, guess what happens? It becomes 200 times, let me just do it without the dollar sign, times 1.08, right? Remember that? And then it goes to 200 times 1.08 to the 2nd power, and then to the 3rd power, to the 4th power, to the 5th power, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, and then let's say we have at the very end 15th where it's 1.08 to the 15th, okay? So it's not actually 16, it's 15, okay? And so what happens just there, that's just the payment, that payment goes up there. What if we did the other payment on the second month? At the end of the second month, we would have $200 here. And this one goes to, think about it, 200 times 1.08 just to the first power first right now, and then and ultimately we'll go here with 200 to the, well, times 1.08 to the, not 15, but 14, okay, because it did it like 14, from month after second month, from month 2 to 16, there are 14 kind of increment periods, right? And so we have go on and so forth and so forth. We have this third month we put a deposit, right, or put a payment in, and we go and then ultimately this is going to go up to 200 times 1.08 to the 13th power, because from 3 to 16 there are 13 months that go by where the interest accumulates. This is compound interest, okay? So all these compound interest periods, how many will there be? What would happen is in the last month you're also going to go just let's say at the very last payment you just make 200. Okay? So what if you do? So let's go from bottom up right here. See that? That's going to be the future value basically. Okay? And this future value is going to be, okay? Let's do this. Let me write this. Future value will be. Let's just, instead of 200, let me just go ahead because I have to finish this up. The payment. Okay? So payment. And then we're going to do payment plus a payment that's like the one that actually 1.08. Let's do 1 plus the R basically. Okay? Let's do that. Okay. And then let's do plus a payment times 1.R squared. And then we go all the way to when we have that, again, it's a little bit rushed, I know, but then the 15th, the 14th, the 15th powers. So we would have, remember, we have periods, how many? 16, right? The 4 times the 4, the number of total periods. So let's say we have PMT times 1 plus R to the, let's say kind of 14. That would be the MT minus what? Minus 2. And finally, let's call that actually, let's call MT, let MT the number of periods, total number of periods, okay? Equal actually to like P, right? Why not? Like, or X. Let's call it X. So this is going to be X minus 2, and then that's a 14, right? Like that. And then this is plus a PMT times 1 plus X to 1 plus R, to the, 15 was actually that 16 minus 1. So you kind of, because you have one less, right? If you, after 1 month, and then it goes from 1 to 16, there's 15 accumulations, right? Not really 16, because you started kind of accumulating after 1 month. So this is actually going to equal to, by the geometric series, okay? I don't have time to really show this right now. It's going to be PMT times, okay, everyone? 1 plus R to the power of X, okay? Just the 16 minus a 1 over this 1 plus R, okay, minus a 1. And this is going to turn out to be a formula PMT times 1 plus R. Let me kind of make it a little neater here. 1 plus R to the, that's where this comes from. It's a little tricky formula. Okay, minus 1 over, if you see the bottom, it just cancels to R. Okay, and so let's do our example here. Okay, watch this. The future value will equal to the payment's $200. Let me show you how this works, and I'll give you the formula. Okay, 1 plus R. Well, R is actually, what do we do? 8%, and we did 4 times a year. So it would be 8% over 4, the M, right? The 4. To the what? We had 4 times 4, 16. Let me do it 4 times 4, right? Because 4 years of 4 times you do it quarterly. Minus a 1 over just this interest rate, 8% over the 4. Okay, that's the one you do every 3 months. So let me do that and that. And that's going to be, let me do let me do the calculator real fast. Okay, so 0.08 divided by 4, that's going to be, 2%. So, 1.02 to the 16th power, right? Minus a 1. Then we're going to divide that by 0.02, and then we're going to multiply that by 200, and we get, what we're going to get, everybody? $3,727.86. Now, guess what? That's bigger than the 3,200 we were actually putting in, okay? Just keep that in mind. So we did win. And how much did we win? 527. So actually we got extra interest earned. Interest I earned. Kind of interest, right? Is equal to the future value minus the present value. In other words, the principal that we got, and that's going to be, see that it's going to be $527.86. Cool. So that we won that, okay? And the idea being that the formula finally would be, watch this, future value is equal to the payment made, right? Kind of what we did there, times 1 plus R, but not R, but I, okay? Let me call it R over the M, okay? Let's use that formula. Remember, that's what I is, the actual interest per that period. And then to the M t power, that's how many periods there are, minus 1, all over, not r, but r over m. Okay? That interest per period. That's our formula, okay, everybody? And that's a pretty cool formula. You can use it to find how much future value you'll get. Like, let's say you deposit money into a bank account, let's say in the savings account. This is what we did. $200 every month. And you do it, well, every 3 months, sorry. Okay? $200 in the savings account every 3 months, every quarterly, right? For 4 years at an interest rate the bank will say, I mean, it's too much. Usually a bank doesn't do that, but 8%, right? Then you would actually win or earn $527.86 more on top of the $3,200 that you're actually putting in. Okay, thank you everyone for watching, and I hope you enjoyed it and learned something interesting.